Let's do a problem from your lab assignment, section 11.8. This is problem number 2. Find the radius of convergence and interval of convergence for the series. The series is x minus 13 to the nth power divided by n squared plus 1 as n goes from 0 to infinity. Again, we will use the ratio test to determine the radius of convergence. The ratio test takes a look at the ratio of two consecutive terms. And for the series, and for n in the series, we're going to put in n plus 1. So we have an n plus 1 in the power. We have an n plus 1 in the denominator before we square it. And then we're going to divide by the nth term, which is really what we're seeing in the series. So that's x minus 13 to the n divided by n squared plus 1. And we're going to use the reciprocal rule to solve for this. And if we do that, we have an n plus 1 or n squared plus 1 that goes in the numerator. And then we have an n squared, n plus 1 quantity squared plus 1, which is FOILed out. So what happens to the x's? This stays in the numerator. There's an n plus 1 x minus 13s. And here is an n number of x minus 13s. So that's going to leave us with 1 x minus 13 left. So now that we have that, the x minus 13 is independent of n, which is where the limit happens. And so all we care about what happens with n is n squared plus 1 in the numerator and n squared plus 2n plus 2 in the denominator. Now, these are matching degrees in the numerator and denominator. So the limit of that as n goes off to infinity is really just the coefficients, which is 1 divided by 1, and that's just equal to 1. So now that we have that, all we have left is the x minus 13, but that is in an absolute value. So we have x minus 13 and we have times 1. So all we have left is x minus 13. So this is essentially our L. In the ratio test, we found the limit, and the limit is L. So we know that the ratio test, as long as L is less than 1, then the series is going to converge. So we're going to set an inequality with absolute values where x minus 13 is less than 1. So that means that the radius of convergence here is going to be 13. If we solve for this, we will have negative 1 less than x minus 13 less than 1. And then we would add 13 to both sides, and we'll see that it's the distance from the center point to the edge would be 13. So the interval of convergence, and the interval of convergence is at least as follows. So it's at least, let's see, let's do that in our heads again. We have x minus 13. On the right side, we're going to add 13 to 1, so that's 14. And on the left side, we would have negative 1. So negative 1 plus 13 is going to be 12. Oh, I think I made a mistake when I said that the radius of convergence is 13. The radius of convergence is not 13. The radius of convergence is 1. I guess a good situation or a good thing to try to do is to imagine what this thing looks like in a number line. So if we have a number line, our center point is 13, and then we are 1 unit away on the right side and 1 unit away on the left side. Let's say that's actually equal to 12. And so a radius of convergence, we know that it's going to converge everywhere within the radius of convergence. So that's 1 unit away on the left and 1 unit away on the right. So the radius of convergence is 1. And we know that we're going to go up to 12 on the left side and 14 on the right side. But it's still kind of a question whether we should include 12 and 14. And so for that, we must check the endpoints. So to check the endpoints, we'll start with 14. So we'll start with 14 to see if we're going to include that. And what we're going to do is take x is equal to 14 and put it into the series. If you put it in a series, you're going to get 14 minus 13, which is 1. Technically, it's 1 to the nth power, but, of course, that's equal to 1. And so if that's equal to 1, this can be compared to the p-series. And we know that the p-series, where the power is bigger than 1, is going to converge. So that series must also converge. So n plus 1 is bigger than n, which means the reciprocal will be less than. And so by the comparison test, this will also converge. So that converges, and so we know our interval will include 14. So we can shade that. Now x is equal to 12. When x is equal to 12, we're going to put 12 in here, and we're going to get negative 1 to the n. Now this is an alternating series, and so this must also converge. So let's see what they have here. Actually, we don't really need to do this because we know that the first one absolutely converges. So if we put an alternating series there, it's also going to converge. But let's see what they say. Applying the alternating series test, we have that the limit as this thing goes to infinity is going to be 0. And the sequence b sub n, absolute value, is decreasing. So the series is convergent. So the series is convergent. That means now we also know that we get the shade in 12. And so your interval is going to go from 12 to 14. And it actually includes 12 to 14. So when we have an inclusion interval, we use the square brackets. Okay, so that's how we find the interval of convergence. Hope that helps.